Hello my dear students, welcome to Deeksha Karnataka YouTube channel, and in Masterstroke series today I am going to discuss dual nature of radiation and matter, right? So this is a medium weightage, medium important chapter, and the length of the chapter is also not very huge, so I am expecting to complete this chapter within 40-45 minutes, right? So don't go anywhere. If you have any doubts related to this chapter, please go through the entire lecture so that all of your doubts, all of your concept gap are cleared, right? So let's start. And before I continue, I just wanted to tell you that watch till the end. There is a surprise waiting for you, so don't miss out on that surprise, right? So first we will start with the what we are going to study today, that is the list of content. So first is electron emission. There are three different types of electron emissions. Then we will come one of the emission, that is photoelectric effect. Then we will go through the observations and what is the meaning of that observation. We'll also go through Einstein's equation. We will discuss about photons, okay? So something new will be discussed, and de Broglie wavelength, that is very important concept for both board and your KCET exam. So let's continue. So first is electron emission. So what is the meaning of electron emission? We know that metals, they have a lot of free electrons. Free electrons in the sense they are allowed to move freely within the metal, right? So they are moving freely, but they cannot come out of the metal, right? So there are three processes through which you can extract electrons from the metal, okay? The three common method are thermoionic emission. Thermoionic emission means you are heating the metal and the metal is emitting the electron, okay? Because the energy of the electron is so high that electron is coming out of the metal. So this is called thermoionic emission, one of the oldest method, and through which many experiments were performed using this method. Second method is field emission. So field emission is you apply a very high electric field and electrons comes out of the metal and they becomes free. So that is also called field emission. Field emission sometimes we see in case of high electric field, when electric field between two objects are very high, okay? Then what happens, the electrons, whichever has higher electron moves in the opposite direction of the electric field, and it basically gives you the field emission, okay? Field emission is due to electric field. Thermoionic, the name suggests thermal means heat, so thermoionic means thermal emission. Field emission is electric field. And last but not the least, the chapter is about is photoelectric emission. So this is very interesting aspect. So what is photoelectric emission? Photoelectric emission was when you shine photo means light, okay? So when you shine light on certain metals, they emit electrons, okay? So emission of electron from the metals by light of suitable frequency, these electrons are called photoelectrons, okay? And this process is called photoelectric emission, and the effect is called photoelectric effect. The entire chapter mainly based on this one type of emission, that is photoelectric emission. Now it is very understandable that if you heat metal, electron starts vibrating, and because of the vibration its energy increases, and when it reaches certain threshold it comes out, okay? Same goes for electric field. So electric field means electrons are under external force, okay? Electric field applies force on electron in the opposite direction of electric field, Q into E, and because of that, when the force exceeds certain limit, the electrons are free. But why on the earth that the electrons are becoming free? Due to the presence of light. So that is something very weird, and more weird thing is that it happens only for certain frequency. So that's why it is something that gives even Einstein his Nobel Prize for the explanation of this process. So that's why it is very important part of physics. It actually opened a new door for entire physics branch, and that's why it is very important. Let's continue. So first, Hertz, okay? Hertz was the first person who observed photoelectric effect. When light falls on a metal surface, some electrons near the surface absorb enough energy from the incident radiation to overcome the attraction of the positive ions in the metal of the surface. After gaining sufficient energy from the incident light, the electron escape from the surface of the metal into the surrounding space. Now during this point of time, the electron was not discovered. Okay, in 1897 J.J. Thomson discovered electron, but when Hertz observed, it is way before, some few years before Thomson's observation. So Hertz observation was the first. He observed some negatively charged particle is coming out from the metal surface when you shine light onto it. Okay, so that is the beginning of our atomic theory. Now, so at that point of time, electrons are not known, only negative particles are known. And what are those negative particles? Later on, J.J. Thomson discovered it, and he named it as electron. Okay. Next, Hallward and Leonard's observation. Hallward and Leonard's observation happened after the discovery of electron. So what they did, they performed an experiment based on the old notes of Hertz, okay, Henrik Hertz. So they performed an experiment. So it was found that certain metals like zinc, cadmium, magnesium, etc. responded to only ultraviolet light for observing photoelectric effect. So they were studying, Hertz already published his paper on photoelectric effect. Okay, he termed he coined the term photoelectric effect because it is happening because of photo or light. Photo is the Latin name of light. Okay, from there the term photon came into existence. So photo or light actually producing this effect, that's why this effect is termed as photoelectric effect. And Hallward and Leonard, they even proceed further with this experiment, and they observed that zinc, cadmium, magnesium, etc. they are giving up electron only for ultraviolet light. Okay, so something is weird about there. If it is a photoelectric effect, any light should give photoelectric effect, because if it is just the transfer of energy, okay, like heat energy, when you are heating the object, the electrons getting heated up and they start vibrating, they are coming out. Okay, that is the basic process. If the same thing is happening with light, why only ultraviolet light? If you put a red light also, the electron will absorb the red light, it will start vibrating more, it will start absorbing more and more energy, and it will slowly become free. But that is not happening. So that is why it is something the scientists thought, okay, something weird is happening, we need a new theory for this. Okay, however, some alkali metals such as lithium, sodium, potassium, cesium and rubidium were sensitive to even visible light. So ultraviolet light has a high frequency light. Visible light is slightly lower than ultraviolet light, but some metals showing photoelectric effect for visible light, some light is showing photoelectric effect for ultraviolet light. So this is not uniform, something is fishy over here. Okay, all these photosensitive substances emit electrons when they are illuminated by light. After the discovery of electrons, these electrons are termed as photoelectrons. The phenomena is called photoelectric effect. Okay, let's move on. Before I continue, I just wanted to tell you that if you are preparing for your KCET 2026 exam, then we are launching our KC30 batch, completely taught in English, and this is a 30 days live online crash course. Okay, here you will get KCET previous year questions with solution. You will get complete syllabus revision, PU1 and PU2 entire syllabus will be covered in this crash course. Chapter wise KCET PYQs in a test format, so you will get the chapter wise KCET PYQ quiz as well. Also you will get 10 full length KCET mock tests. Okay, so including everything you will get the price only for 2499, and this is introductory price, the offer valid till 25th of February. Okay, after 25th of February the price may go up, so don't wait till 25th of February. The course is launched. You can click on the link given in the description of this video and register yourself. The batch starts from 21st of March after your PU exam is over, but if you register today you will get this introductory price of 2499. There is a high chance that the price will go up after your PU exam is over, right? So don't wait, book your seat today, right? So the batch is KC30. it is exclusive KCET 30 days crash course online batch, and that we are going to teach you in that crash course, right? Let's continue with our discussion. Now, photoelectric effect of intensity of light in photocurrent. So when the number of photoelectrons are emitted per second is directly proportional to the intensity of the incident radiation. So the photocurrent, what is current? Current is number of charges per unit time, right? So Q by T is called current. We already studied in electric current chapter. So photocurrent is basically when you are applying some light onto a metal, some electrons are coming out, and when these electrons are coming out, you are collecting it and you are checking how much current is flowing in the circuit. So for that they designed a simple experimental setup. There is a glass tube. Let me switch the color. So they had a glass tube like this. Okay, so glass tube was like this. In this glass tube there was an opening, specifically from where you are shining light. There was a metal plate like this. There is a battery to control the current. Okay, now when you are shining some light onto this, what happened is that electrons are basically flowing. So electrons are flowing in this direction, so you are basically getting a current in the opposite direction, right? So you are basically getting a current in the opposite direction. Some rheostat is fixed. Now you can change this input voltage, which actually tries to calculate the current by reversing the voltage. Okay, that is the purpose of this power supply. This is also variable. Resistance and voltage are variable. So this is a very simple experimental design by Holwach and Leonard. Okay, so they shine some light on this metal. This is the active surface, and from this electrons are emitted. So if you can collect the electron on this surface, you are going to say okay, this much current is being flown in this circuit. Okay, so this is how the experiment was done. Experimental setup is not part of the syllabus. You don't need to put too much attention on this, but you need to know how the experiment is performed. Okay, that is how you can understand these graphs as well. Okay, so what he observed is that the current is proportional to intensity. Intensity means more bright is the light, more current you are getting. Okay, that is very obvious. Okay, the saturation current is independent of the frequency of radiation. Saturation current means when you have switched on some light and the current stabilizes. Current is stable, so you are getting a long term same current for some time, and that is basically called stabilizing current. And that stabilizing current is actually independent of the frequency. So frequency, even though frequency is important to start the process, okay, when you are getting the current is not dependent on frequency of light. What else? Effect of, so if you plot the graph of photoelectric current and intensity of light, it is directly proportional. So it is a straight line graph passing through the origin. Obviously if the intensity is 0, you are not going to get any photoelectron, and as you are increasing the intensity of light, you are getting a straight line graph. So it is a directly proportional graph. Next, effect of potential on photoelectric current. So if you the potential that you are applying, so that you can keep the charge 0, you can keep the current to 0. Okay, so that's why the battery is connected in reverse order. Okay, if you go back in previous part, okay, the battery is connected in the reverse order. Current is trying to follow in this way, but this is trying to stop that current. Okay, so that you get an idea, okay, how much potential you need to stop the current which is trying to flow in this particular order. So electrons are flowing in this direction means current is flowing in the opposite direction, right? The current is actually the opposite direction of current, electrons, and you have connected this source such that it actually tries to stop this current. So that is why it is called stopping potential. Okay, so when you are applying a potential in the reverse direction of the current that is being produced in the circuit, okay, the maximum value of the photoelectric current is called saturation current. Saturation current corresponds to the case when all the photoelectrons emitted by the emitter plate reach the collector plate. So the emitter plate names obviously very easy to understand. Emitter means who is emitting electron, the active plate, and the collector plate is which is connected to the battery which is collecting the electrons. The minimum negative or retarding potential, that's why the battery is connected in reverse order to stop that current, to measure that current. Okay, the minimum negative potential V0 given to the plate A, for which the photocurrent stops or becomes 0, is called the cutoff or stopping potential. Okay, this is the stopping potential. The stopping potential does not depend on the intensity of the radiation, it is only dependent on frequency. So something is dependent on intensity, something is dependent on frequency. So both are important here. So if you reverse the voltage, that's how we have done it. Okay, when the voltage is reversed, you will see that the current, all the current, which whatever is the value of the current, they are all merging at a single point. Okay, they are all converging at this point. So this is the stopping potential. Stopping potential is independent of intensity. So current, the saturation current or the maximum current is proportional to intensity. Higher the intensity, higher the saturation current. So you can see that here the saturation current is more. So for this I3, the saturation current is more. For this, saturation current is slightly less. This is also slightly less. So they all have different frequencies, different intensities. I3 greater than I2 greater than I1. But the frequency of light, now frequency is represented using this symbol, which is called nu. Okay, this is called nu. Okay. Now it is written as nu, but it is pronounced as nu. Okay, so this frequency is same for all these three radiation, and eventually the stopping potential is also same for all of them, right? So weird, current is different. Higher current also requires same stopping potential, lower current also requires same amount of stopping potential. Okay, so these are the all observations of Hallward. Effect of frequency of incident radiation on stopping potential. Okay, so the magnitude of stopping potential increases with an increase in the frequency of the incident radiation. Note that saturation current is independent of frequency. So as you can see here, now what we are doing, we are using three different frequencies, but intensity of light is same. Intensity, three different lights, for example, say ultraviolet, X-ray and gamma ray. We are taking zinc for example, and we are using three different frequencies, but the intensity is same. So the brightness of all three lights are same, but frequency is different. Okay, gamma ray has highest frequency, then X-ray is intermediate, and ultraviolet is the lowest frequency of these three. So in this case, what you observe that when you are increasing the frequency, okay, the stopping potential also increases. So stopping potential or the negative potential required to stop the flow of current is proportional to the frequency. So more the frequency, more is the stopping potential. Okay, now let's see one question in KCET based on this diagram. The same question came in Comet K exam as well. Okay, so let's see. The following graph represents the variation of photocurrent with anode potential for a metal surface. Here I1, I2 and I3 represents the intensities. Nu1, Nu2 and Nu3 represents the frequency of curves 1, 2 and 3 respectively. Then which of them is correct? So as you can see that this is say intensity, this is Nu3, this is Nu2, this is Nu1. Intensity for this is say I3 and I2. Okay, 2 and 3 are same, and Nu1 is the intensity of light for 1. So as you can see from this given information, what is correct? Obviously both of these two lights have same frequency, so Nu2 must be equals to Nu1, and both of them should be less than that of Nu3. Nu3 must be greater than both of them, because Nu3 has higher cutoff frequency or higher cutoff voltage. Okay, stopping potential is more for Nu3, so Nu3 must be big brother than gamma 1, Nu1 and Nu2. Now as you can see, photocurrent is same for I2 and I3. So if photocurrent is same, that means intensity must be same. So I2 must be equals to I3, and both of them should be greater than that of I1. Both of them should be greater than that of I1, because current, saturation current is less for I1. Now let's see the options. Nu1 equals to Nu2, Nu1 equals to Nu2 and I1 equals to I2. So Nu1 equals to Nu2 is correct, but I1 is not equals to I2. Okay, so I1 is not equals to I2, so this portion is wrong. So this is a wrong statement. Nu1 equals to Nu2 and I1 is not equals to I2. So Nu1 equals to Nu2 and I1 and I2 are not equal. This is correct, this is also correct, so this statement is correct. Okay, fortunately our second statement comes out to be true. You can check the other options as well. So for example, in this case the second option is given correct, but the first option is wrong. Here also first option is wrong. Okay, nu2 is not equals to nu3. So from there we can say that this is the correct statement. Both conditions are satisfied. Nu1 equals to nu2 and I1 is not equals to I2. So this is a correct answer for this question. This came in KCET I think 2023 or 2024. Let's continue, and the surprise that I was talking about is that you can get a free KCET mock test paper including physics, chemistry and maths. The link of that is given in the description section of this video. So if you want to download the PDF, what you have to do, you have to click on the link given in the description section, free KCET mock paper. It is mentioned like this, free KCET PCMB mock test PDF. Click on the link, register with your phone number, put on the OTP, and you can download the free PDF for your KCET 2026. Okay, so this is absolutely free of cost, no charge required, no hidden charges are there. Okay, only thing you have to register with your mobile number, put the OTP and download. One mobile number can download only once. Okay, not more than once. Once you have used the mobile number, you will not be able to download the PDF once, but once you have downloaded, it will be staying with you forever. Okay, you can use it, you can take a printout, you can share with your friends, but ask your friends also if they require it, register it from here so that they get the actual paper and use them by themselves. Okay, so end of this video, at the description section you click on the link given over here and you will be redirected to Vedantu website. There you have to put on your mobile number, register yourself, get the question paper. Okay, so this is the big surprise, complete free mock test, and it includes physics, chemistry and mathematics as well as biology. Next, photoelectric effect observations. What are the observations? The stopping potential V0 varies linearly with the frequency of incident radiation for a given photosensitive material. As I mentioned, this is true, and if you plot the graph, you will see that the nu0 for certain value there is a value over here, and beyond that it is directly proportional. So it is not starting from origin. Okay, so stopping potential is 0, not even for zero frequency. It has to 0 from certain starting potential. Okay, there exists a certain minimum cutoff frequency nu0, certain minimum cutoff frequency nu0 for which the stopping potential is 0. So this is the starting point. Okay, this is the minimum frequency for which the stopping potential is 0, and as you are moving the frequency upwards, the stopping potential also increases, the cutoff potential also increases. Very important thing, it is not 0. Frequency is 0 even for a given frequency. It is unlike the photocurrent versus intensity graph. Photocurrent versus this is current, this is intensity. It was a straight line graph, but it started from the origin, whereas this is not starting from the origin. It is starting with a x, what should I say, there is a x axis on this, there is a cutoff here. Okay, so there is a cross over here, and that value is called nu0. Okay, the maximum kinetic energy of the photoelectrons varies linearly with the frequency of incident radiation, but it is independent of the intensity. So maximum kinetic energy, again kinetic energy is dependent on the frequency, but it is independent of intensity. So intensity is only determining the current, in whether it is the cutoff voltage, whether it is the maximum kinetic energy of electron, they both are independent of intensity. For a frequency nu of the incident radiation lower than the cutoff frequency nu0, no photoelectric emission is possible even if the intensity is very, very large. This minimum cutoff frequency nu0 is called threshold frequency. It is the different it is different for different metals. So threshold frequency is the, so when you are crossing a door, there is a bar there. Okay, initially in the older houses you may have seen that there is a stopping thing that actually you have to cross, that is called threshold. So once you cross the threshold, you enter the room, or once you cross the threshold, you comes out of the room. Okay, so threshold is basically the bar through which you enter a room or exit a room. Okay, so this is the basically the threshold frequency for which you will observe photoelectric effect or you will not observe photoelectric effect. Okay, so there is a minimum value of this frequency, and only at that minimum frequency and above you will observe photoelectric effect. Any frequency lower than that, no matter how many lights you are using, you will not observe photoelectric effect. Okay, photoelectric emission does not take place by continuous absorption of energy. Now Einstein's explanation, but just a second. Now before I continue with the Einstein's photoelectric emission, just wanted to tell you one more thing. So for any light greater than threshold frequency, okay, so there should be one more point, any light greater than threshold frequency, okay, so if the nu is greater than nu naught, okay, you will observe photoelectric effect with a very low intensity as well. Okay, so intensity low, very low, will still give you photoelectric effect, will still give you photoelectric effect. Okay, but if it is smaller than nu naught, no matter how bright is the source, you will not get any photoelectric effect. Okay, so frequency greater than nu naught, you will get plenty of photoelectric effect with a very small or low intensity. But if the frequency is smaller than this value, no matter how many light you are switching on, it will not give you any photoelectric effect. This is very, very interesting. Now for that we need a new theory, and Einstein actually gave the theory for that, and which was actually experimentally verified, and because of this Einstein was awarded Nobel Prize, even though he has done a lot of other stuffs, but he got his Nobel Prize for the explanation of photoelectric effect. Photoelectric emission does not take place by continuous absorption of energy. So continuous absorption means I am giving you food, you are eating slowly, and everything you are eating, and that is increasing your weight. So that is continuous absorption, you are continuously eating. Okay, that is called continuous absorption. For example, if you heat certain material, certain metal, okay, metals will continuously absorb the heat energy and electrons becomes free. That is called continuous absorption of energy. But for metals, when they are subjected to light emission, it does not have the same process of thermionic emission. Thermionic emission is a continuous absorption, whereas photoelectric emission is not continuous absorption. It is not continuously eating energy. Radiation energy is built up of discrete units, the so-called quanta of energy of radiation. So what is the quanta of energy? Quanta of energy, as I mentioned, is the minimum value. So for example, you have learned quantization of charge. Charge has a minimum value of small e. Similarly, all radiation basically have a minimum energy, and that minimum energy changes with the frequency. The minimum energy that carried by a radiation depends on its frequency. Okay, so that is called discrete. It is not continuous. Light is not continuous, but it is made up of discrete energy packets. Okay, energy packets like the biscuit packets or milk packets. Each packet of biscuit contains certain number of biscuits, right? As you are going up, you will get to buy more biscuits, you have to buy a larger pack. Similarly, each packet of photons require has a fixed amount of energy in it. Okay, so if you want to buy a larger packet, you have to move up the frequency. As you are going higher the frequency, energy packet size will increase, but for a given frequency each energy packet is same. Okay, so for example, 5 rupee biscuit, if you are purchasing a 5 rupee Parle-G, then there is a certain number of biscuits inside that Parle-G packet, right? Similarly, if you want to purchase, say, another biscuit which is for example, you want to buy Chocolato Pie. Chocolato Pie, one packet has only one biscuit, but if you are buying a big packet, that will cost you more, and that will have more than, but each of them will still have one packet each, right? So does not matter you are shining a big Chocolato Pie box or a single Chocolato Pie, both, each of them will have the same number of biscuit, that is equals to 1. Okay, So imagine this as chocolate pie biscuit. Each quantum of radiant energy has energy equals to h into nu. H is a constant which is known as Planck's constant. Okay, I will tell you a small story after this. Planck's constant and nu, the frequency of light. The maximum kinetic energy of the emitted electron is given by Einstein's photoelectric emission equation, which is given by Kmax. Kmax is the maximum kinetic energy, equals to h nu minus phi naught. Okay, phi naught is the threshold energy. Okay, so light of two different frequencies whose photons have energies 1 electron volt and 2.5 electron volt respectively successively illuminate a metallic surface whose work function is the phi naught value is 0.5 electron volt. Ratio of maximum speeds emitted by the electrons will be. Very interesting, easy problem. So far we have learned that Kmax is given by h nu minus phi naught. Okay, now h nu is the energy of the photon. H nu is the energy of the photon. And what is Kmax? Kmax is kinetic energy. So what is the formula for kinetic energy? Formula for kinetic energy is half mv square. What is m? M is the mass of electron. Okay, so half mv square is Kmax, right? Now in this particular problem there are two sets of energies, 1 eV and 2.5 eV. Okay, so half m v1 square, that is the for the first case of 1 electron volt, okay, is h nu is 1 electron volt. H nu itself is the value, and the work function or phi naught is given by 0.5 electron volt. So half mv square is 0.5. What about half m v2 square? Half m v2 square, for v2 the energy is 2.5 and it is minus 0.5. Threshold frequency is same, so it should be 2. Now you have to find the ratio of these two. So ratio of these two is v1 square by v2 square, and that is equals to 0.5 by 2, that is 1 by 4. Okay, so now you have to take the square root. So v1 is to v2 equals to 1 is to 2. So correct answer is 1 is to 2. Okay. So this is how you should tackle problems based on this chapter. Okay. Now in the equation the work function is given by phi naught equals to h nu naught. So phi naught as a whole, if the value is given, very good, simple problem, but in some cases they will give you threshold frequency. So in terms of threshold frequency, the minimum energy required to release the electron is given by h nu naught. So that now you understand why there is a threshold frequency. So this minimum threshold frequency is required to release the electron. So electron basically when they are orbiting inside an atom, they are orbiting on orbits. Okay, I am not going into orbital theory, I am just going into the most simplified version of orbits. Okay, orbital is, you have learned in chemistry, sir, you will say, sir, orbits theory is not complete, you need orbitals. I am going into more simplified theory of orbits. Okay, so here there is an electron which is the outermost orbit. Okay, so this is the outermost orbit, and this is the if electron can jump from here to here, it will be free. Okay, this is the free, this will be completely free of the attraction of the atom. Okay, so positively charged nucleus is there, and when the electron is orbiting around this nucleus, you require certain amount of energy to make it free. Now electrons, as I mentioned, for like you or me, when we are eating, we are continuously gaining energy. Electrons cannot eat continuously. Electron requires only one packet of food. It will eat the entire packet of food, and if it gains enough amount of energy, it will go out. If the energy is not sufficient, it will not eat that packet at all. Okay, so it will not sufficient for it. It will say, okay, I will not eat any food. Either you give me 1 crore rupees, I will take it and grant you the permission, or I will not take a single money. So like that. Okay, so the electron requires minimum this much amount of energy to become free. Any extra energy given to that, it will give the kinetic energy. for the electron. But if the minimum energy is h nu naught, it will just come out and it will say I am free, right? After the KCET exam you will say, or after your PU exam, for some of you will say after PU exam as well, right? I am free. Okay, so electrons are also appearing for PU exam, so they need minimum this much passing mark to become free. Okay, if they are not getting that passing mark, they have to reappear in the exam 2, exam 3, and maybe possibly next year as well, right? So this is the way of becoming an electron to make it free. Okay, so the equation of the work function is given by phi naught equals to h nu naught. This is the minimum energy required to free one electron. Here nu naught is the threshold frequency. Everything we have discussed. The Einstein's photoelectric equation in terms of stopping potential. So we have seen stopping potential when you are trying to stop an electron from going into the collector plate, and that stopping potential, in terms of stopping potential, the kinetic energy, the maximum kinetic energy of the electron is given by EV naught. V naught is the stopping potential, E is charge of an electron. So when an electron is being stopped by certain potential, this is the maximum kinetic energy, and that maximum kinetic energy is h nu minus nu naught. Again, phi naught is given by h nu naught, so it will be EV naught equals to h nu minus nu naught. So this is the formula that you should remember. Okay. Now I just wanted to tell you one small little story, that the Planck's constant that you are seeing over here, h, it came from some experiment done by Max Planck on his thermal radiation theory. Okay, he was saying that the thermal radiation is also quantized, so he gave the thermal radiation quantization theory. But when he showed his research paper to Einstein, Einstein says no, this is not possible, this is completely ridiculous, it cannot be correct. Okay, but later on when Einstein came to explain this photoelectric effect, he had to borrow the idea of Planck's, and then he was not original in a sense, okay, because Planck's constant, everything was actually done by Planck's. That's why we are using Planck's constant over here. Max Planck is, you can read about Max Planck on Wikipedia or on a website. Okay, he's a brilliant scientist. Okay, and they are almost Einstein and Max Planck, they are all simultaneously did a lot of study together, and Einstein actually ridiculously said that no, this theory cannot be correct. But later on when it came to photoelectric effect, then he realized, okay, Planck was correct. Now I had to borrow his constant and his idea into this field, and we have to explain it using that quantization theory. Okay, so quantization, the idea of quantization was not Einstein's original, it was actually Max Planck's. Okay, but he did it for some other part of heat radiation experiments, and Einstein did it for photoelectric experiment. Okay, so when you are copying from your friend, remember that you should not ignore your friend's ideas, saying that okay, he is writing bullshit, I will not copy it from him. You should copy it, but you should copy it in a separate case, so that the invigilator who is observing you, or the examiner who is checking your paper, they should not understand that you actually have copied. So smart is better, right? Jokes apart, let's continue with the discussion of photon. Okay, an interaction of radiation with matter, radiation behaves as if it is made up of particles called photons. So for example, when I want to throw a ball, okay, onto another ball, the ball will collide, they will scatter, right? So this is called interaction, collision basically. Okay, so one ball can collide with only another ball. Okay, but if I throw the ball through air, okay, the air, even though it's light, it does not interact too much with the ball. Okay, the interaction is very minimal. So but if I want to interact with something such as ball, I need something solid. Even the ball will not interact too much with water as well. Okay, it will come to a stop immediately after coming into contact, okay, after few seconds. But when you hit the ball on a solid surface, the ball bounces, right? For example, the cricket World Cup is happening, Hardik Pandya is bowling a ball, the ball bounces after pitching on the surface. Okay, but he is saying that okay, I want to bounce the ball from the air itself. That is not possible. You can move the ball in air, but you cannot bounce the ball in air. So interaction is limited when it is interacting with other materials, but interaction is very much prominent when it is interacting with the solid surface. So photons, when they are interacting with solid materials, for example electron, okay, it has to behave like an electron. okay, but light is not a solid like electron. So what do we say? We say that when they are interacting with something like electron, they are actually behaving like matter particle, and that matter particle is called photon. Photon is the matter name of light. Okay, each photon has energy of h nu. This is the energy packet, and momentum equals to h nu by c, and speed of the light is c. Obviously, all photons of light are particles of frequency nu or wavelength lambda have the same energy. So if you say that light is basically very uniform, all the photons have same exact amount of energy, okay, for a given frequency or given wavelength. Okay, for example, if you take red light, all the red light particles, they will have the same energy, no matter if you are performing the experiment in Bangalore or New Delhi or in Washington or some other place, or say in moon. Okay, all the red light, they will have the same amount of energy. Okay, and that energy and momentum as well. The momentum is given by h nu by c, energy is given by h nu or hc by lambda. Okay, when solving problem, remember h into c is 1240 electron volt. That will be very handy, especially for KCET problems where they will ask you the same question based on wavelength lambda. So in that case, hc equals to 1240 electron volt is very electron volt per nanometer is important. Okay, sometimes they will give you lambda in terms of nanometer, and they will ask you what is the energy associated with it. So if you put 1240, easily you can convert it into electron volt. Electron volt and nanometer conversion happens through this value. Okay, photon energy is independent of intensity of the radiation. Okay, so intensity means more number of photons, whereas energy of a single photon is same. Okay, so basically it is like a drop of water. Each drop of water have a fixed amount of mass, fixed amount of everything, but intensity means a very huge amount of flow of water. But if you take the flow of water, each drop will still have the same amount of mass, same amount of everything into it, right? Similarly, so you can consider the photon to be the drop, and intensity is the number of drops that you are being that is being flown into the pipe. Clear? Intensity represents number of photons, and energy is being represented by one single photon. Photons are electrically neutral. So these are the properties of photons, very important point to remember. Photons are electrically neutral and are not deflected by electric and magnetic field. So based on this concept, we have seen some objective question came in the past, MCQ questions. In a photon particle collision such as photon electron collision, the total energy and the total momentum are conserved. However, the number of photons may increase or decrease. Okay, so if you say that electron and photon, when they are colliding, okay, even in that case the total energy is still conserved, and maybe one photon will break into two, or two photons will merge into one. That is still possible, but the total energy will always be conserved. Okay, the photon may be absorbed or a new photon may be created. That is also possible. So if you are throwing a photon towards an electron, might absorb the complete photon, or highly excited electron, when they come down from higher energy to lower energy, it will emit a photon and a new photon is created. So photon creation and absorption is possible, but total energy should remain always constant. Now, wave nature of matter. So here comes a history student, okay, in a famous university in Germany. His name was Louis de Broglie. Okay, so Louis de Broglie, when the Einstein discovered photoelectric effect, you all know that Einstein was a German. Okay, even though later on he shifted to America, but people of obviously someone of Indian origin does something great in outside India, we all keep an eye on the news, right? For example, the CEO of Google, CEO of Microsoft, they are all Indians. So we feel proud within ourselves, right? Similarly, Einstein, when he published this photoelectric effect theory paper, okay, all the Germans were feeling proud. They are discussing it in all the universities, and during that time there was a student called Louis de Broglie. He was a humanities student, history student. Okay, he was having a discussion with his older brothers. They are all physics students. Okay, so they used to interact, they used to talk with each other, right? During that discussion, someone said that, you know, that photoelectric effect was discovered by Einstein, and he is saying that light behaves like a particle. It is like a wave as well as a particle, because wave nature of light was already established by Huygens theory. So we all knew that light was a wave, but when Einstein came and explained this, from this explanation it was established that light also behaves like a particle. So this is called dual nature. Dual nature means sometimes it behaves like a wave, sometimes it behaves like a particle. So there, this student Louis de Broglie, he was listening to this, and he said one thing, that nature loves symmetry. What is the meaning of that? So if you see all the natural objects, they are all symmetrical. Okay, for us, example, take me. Okay, I have a right hand, I have a left hand, I have a left eye, I have a right eye. My nose is also symmetrical from both sides. Okay, so if you bisect me from both sides, don't do this, but if you try to bisect me from both sides, it is almost very symmetrical. I have a right leg, I have a left leg. Okay, so most part of human body is symmetrical. Even if you consider the planet where we are staying is a spherical object. Spherical object is most symmetrical object, right? Even though it's not perfect sphere, but it is still almost spherical, and we can say that the nature loves symmetry. Okay, all the universe, even the planets are rotating in almost circular orbit with some elliptical part, but the ellipse is also symmetrical. Okay, so nature, all the natural objects, even if you see the leaves of a tree, okay, they appear on both sides. So leaves are also symmetrical. So he said one thing, that nature loves symmetry. So if a wave can behave like a particle can also behave like a wave. So it was Louis de Broglie's hypothesis. Hypothesis means it was not yet experimentally proven. Okay, so nature was symmetrical, and that the two basic physical entities, matter and energy, must be of symmetrical character. If radiation shows dual nature, so should matter. Okay, and from there the history student, he turned into physics. Okay, he started studying physics, and he gave the theory of wave nature of matter. Okay, that is why it is called de Broglie's equation. And de Broglie said that the wavelength of matter wave, or wavelength of matter which is in motion, can be written as h by p. P is the momentum of the matter, wavelength lambda is wavelength. Okay, later on it was proven by Division-Germer experiment that yes, matters do behave like waves. Okay, that experiment is not part of the syllabus, but again, so from a simple idea that nature loves symmetry, and if energy and matter are two fundamental things, aspects of our universe, okay, if energy is behaving like matter, matter should also behave like energy, or matter should also behave like wave. So that is why it is called dual nature of wave and matter. Okay, so wave is behaving like matter, matter is behaving like wave. Let's see one question. A particle of mass 1 milligram has the same wavelength as an electron moving with a velocity of 3 into 10 to the power of 6 meter per second. The velocity of the particle is, so both of them, 10 to the power values is slightly shifted, please pardon that. Mass of electron is given, okay, and mass of the other particle is also given. So both of them have the same wavelength. So what is the wavelength formula? Wavelength formula is h by p. So mass of 1 mg and mass of electron, both of them have the same wavelength, so that means this must be equal. Okay, or the momentum of the 1 mg particle and momentum of the electron, both of them should be same. Okay, so mass of 1 mg is 1 milligram. 1 milligram means 1 into 10 to the power of minus 3 kg, and velocity say v1. Okay, remember that momentum is nothing but mass into velocity. Okay, so we are taking the masses multiplying with the velocity. For electron, okay, the mass is given 9.1 into 10 to the power of minus 31 kg, and the velocity is given 3 into 10 to the power of 6 meter per second. unit does not matter. Okay, you just need to calculate the value, because obviously the value is important over here. Next is V1 equals to 27.3 into 10 to the power of minus 25 divided by 10 to the power of minus 3. Okay, you divide it on this other side, so you get 27.3 into 10 to the power of minus 22 meter per second. Okay, so the speed of the object will be 27.3 into 10 to the power of minus 22, or 2.7 into 10 to the power of minus 21. Okay, so as you can see, for smaller mass the speed is very small to have the same wavelength as electron. Okay, now this is the end of this lecture, and if you enjoyed today's lecture, don't forget to subscribe to our channel if you have not yet subscribed, and give it a like if you like this lecture. I'll be back with new session. Also, to download the PDF of this lecture, don't forget to join the WhatsApp channel. Link is given in the description. Okay, till the next lecture, bye.